Hello, this is a video for Assignment 1, Duke University, Product Management AI. So this shows the approach I utilized to predict the power output based on the 9,400 rows. The first thing was to establish what features to train the model on. I trained the model initially on the two features, which is A, T, and V to predict PE, and then applied that to the multivariate regression training model in Excel. That was trained on three K-folds data sets, which is showed here. So I split the data sets into four and just utilizing the first two sets to train, and then test it on the third set, and then I carried on testing it on the first and third set, and testing on the second set and third set and second set, and then tested on the first set, and that was used to result in a mean square error score, and then I repeated the exercise with the feature set encased in blue. This time, instead of just the two variables A, T, and V, I also did A, T, and V, AP, and H, as you can see in red. And I then repeated the 3K folds again. I didn't test it on the fourth set because I wanted to keep that separate for the final evaluation. And this shows the output of that evaluation, where here is the output from the four variables, resulting in a mean square error of 20.930, and this shows the outcome of the mean square error prediction using just two variables. So as you can see here, a mean square error of 20 is a lot less than 24.74. So going on to the next slide, I then after concluding that using four variables was superior to using two variables, I applied the whole training set, folds 1, 2, 3, as the training set, and then that was tested against the fourth fold as the as the sample of data that wasn't part of training before, just to make sure that it generalized well. And the result of that, we had a score of 20.93, which shows that the linear regression model generalized well on data that wasn't part of its training data. Yeah, so basically I trained all the three folds here, and we tested it on the fourth and final fold against the training model, and that gave me the prediction. So in summary, the model approach, as the data was structured and labeled and it was continuous numerical, that made sense to use a linear regression model, and after evaluating the using two variables and four variables, I concluded it's best to use the four variables based on the mean square error output of the power prediction. We built the model using Excel's linear regression features, and that allowed us to compare the four variables against two variables and calculate the mean square error. And again, in terms of module evaluation, we're able to use the mean square error to evaluate the two models to show that four variables was superior than to two variables. And in terms of interpretation, the conclusion that we can predict the power output well on data that wasn't part of training. And that concludes my presentation. Please give me a pass. All the best, everyone. Thanks. Bye.